This is addition. The ISO code section prepared by Tornos. This is the last third element of a model, or using the other words, pattern or template. This diagram presents the structure of addition. What is essential in it? First, we have the loops inside. It starts here and ends here, and within this range, machine cycles works continuously in production. Time counted from loop start till the end of a loop is our cycle time. Within this range, we enter ISO codes to program our machining operation in both channels. We have operations initial at the beginning and the other ones at the end of a program. Main and back spindles can work independently and simultaneously, but there are moments of time when it is necessary to introduce synchronizations between them, for instance, to avoid collision. The first block is data storing. It stores as parameters of Tornos macros all data which were defined in part info. Let us try to find connection between such a macro and part info, changing the value, for instance, of allowance for facing in back operation. Let's move to part info and select part, and here we have the 0.2. We can return to the previous value and go to addition, and this change was transferred. We can display in TISIS the full view of a program, I mean all ISO codes, or limit this view only to the content of a loop. We do it by clicking main loop. Please look, when I click main loop, you see only loop, content of a loop. Clicking once more, we have full view. Just after data storing, we have synchronization between both spindles. How do we write synchronizations in our program? Here you have example, and to the right you see the syntax forms of these codes. It can be M9000 to M9999. Those digits after M and interpreted as numbers. It means that it isn't necessary to introduce synchronization codes in a program in ascending order. For instance, I can change this synchronization code. You see, error is already displayed, so I have to change the second one. Error disappeared. It means that it is necessary in a program to enter synchronization codes in pairs, the same form in both channels. If I'd like to return to ascending order, then it is enough to click renumber, and we have the previous value. Next are initial operations in both channels. Let's look into ISO codes. First, let's close in both spindles. After the bar feeder pushes, and below there is M8 coolant on. You see slash at the beginning of M8. This slash makes coolant flow dependent on the state of control panel on a machine. If a button block skip on a control panel is on, then block with slash at the beginning is omitted. In this case, coolant will not flow. It is useful when we test a new program without material and we don't need coolant. Below there is 1 second dwell, and you see Tornos macro G900 in both channels. It calculates 0 offsets for work in main and back operations and stores them in G54 and G55 for work in main and back operations, respectively. You can find a detailed description of this macro G900 as well as the other Tornos macros in programming manual for our DT26 HP machine. You surely noticed these two codes M702. They are connected with PICOF, so we will discuss it later. There was no movement on a machine till now, but next step is referencing. First, in back operation, it is commanded by G28 code, and incremental notation for axes is used. First, back spindle goes fully back, and then it positions in a line with main spindle, as you see in the film. Referencing in channel 1 is next step. First, the whole support goes fully back and moves to the right in y-axis. You see we have here optional equipment b-axis, and it also should be referenced. That is why I've written G0B90. This is reference position of b-axis, as you can see in the film. Simultaneously with referencing in channel 1, we have Tornos macro G919 execution in channel 2. This macro checks what was set on a machine in configuration form. This position is checked. Then, in this way, we can control if a part kept in back spindle will be ejected or not at the beginning of a program. Next is initial cutoff. It is performed by macro G910. It executes cutoff of a tip of a bar to define the position of a face of a bar in the machining area. Please notice that initial cutoff is done at rotation speed and feed rate defined in part info in form cutting this value and this value. Please look also at the final position of cutoff tool at the end of initial cutoff. You see that cutoff tool doesn't retract. It stays below the center of a bar. You see loop start below. It is programmed by M120. This code is synchronization itself. It means that we have to write it in both channels. Just after beginning of a loop, it is necessary to check if we have sufficient length of a bar to produce a next part. It is done, you see here, by Tornos macro G913. This macro executes a sequence of operations in a case when signal end of bar is active. First, please look at this drawing, and as first operation, the tip of a bar is beveled to remove bears. Then main spindle retracts to withdraw a bar from guide bush. After it opens collet and bar feeder removes remnant and ejects it. Then a new bar is loaded by bar feeder and it is pushed to the position in front of guide bush. Then main spindle with closed collet, the same as previously for withdrawing, moves by the distance of h. This parameter has value by default and it is 50 mm. If we need the other value, of course, we can enter it explicitly, like for instance Macro G913 finishes with cutoff of a tip of a new loaded bar. Below you see the other macro, G930. This macro checks the state of a button work with material, this button, on a machine control panel. If this button is off, then the program is executed without machining of a bar. First, a bar is retracted by distance A into guide bush, and then its movement is blocked. The value of parameter A is calculated by default, but of course we can change it. Please pay attention that if we work without guide bush, then there is no retraction, and in this case it is necessary to define the value of A explicitly. The next step is feeding of a bar for a next part. It is done by macro G912. Please look in this drawing to the right. It presents the state on our machine at the beginning of this macro. It means that cutoff tool passed the center of a bar, as you see here in the film also. Main spindle is in forward position with closed collet. And what happens next? Next, main spindle opens collet, bar feeder pushes, and in this situation, cutoff tool is a stopper. It blocks movement of a bar into machining area. Then main spindle retracts by a length sufficient to machine a next part. This length is calculated as sum of these elements. All of those elements were defined in part info. Cutoff tool retracts at the end of bar feeding, as you see in the film and also in ISO code. All conditions are fulfilled now to start machining of our part in both channels. A part can be ejected in channel 2 when machining was completed. Let's look into ISO code. You see G55, stopping rotation, back spindle fully retracted, and then it positions to X0 according to the geometry of T500. So you see this positioning, T500, geometry of that tool is defined. So this is the position of back spindle and in X-axis, and this is in Z-axis, as you see here. After it, collet opens, and next, ejector in back spindle goes forward here. You see it. It pushes a part, and the part drops into this box. After it, ejector retracts, and back spindle also retracts fully back and goes in X-axis in a line with main spindle. The codes beneath in our program will be executed when this synchronization code will be reached in both channels. When a part was machined in both channels and ejected, then we can prepare for pickoff and after it cutoff. This is this block. Cutoff tool is positioned and its rotation starts. I owe you at this moment some words of explanation about syntax of M codes to start and stop rotations. Please look into this drawing. After M character, we put a drive identifier. This is one for main spindle. Next will be specification of rotation direction, I mean 03 or 04 for clockwise or counterclockwise rotation respectively, then S character followed by the value of rotation speed, and at the end we have P character and once more identifier of a drive. So we can say that this group of M codes is dedicated to main spindle. Let us look for M codes for the other drive. We have drive S51 in back operation for rotating tools, and in this case, to start its rotation, we will write M51. 51 is the identifier of a drive, then specification of direction of rotation, value of rotation, and at the end P51 once more. We have rotation speed here of 5000 RPM, but of course we can put the other one. And below there is macro G911. It positions a bar for cutoff, as you see in the drawing. A bar is withdrawn in front of cutoff tool by the part length plus allowance for facing in back operation. And you see a bar is withdrawn. A bar was withdrawn in channel 1 and doesn't move after it, then back spindle can approach for pickoff. Macro G915 is essential at this moment. As you see in the drawing, it shifts 0 in back operation to the face of a bar. Then back spindle approaches to 2 mm in front of a bar. You see it in the film. Next is M418. This code activates synchronization in phase and rotation speed between main and back spindle. Main spindle is a master. Back spindle follows any change in rotation and phase of main spindle. This mode is deactivated by any change of rotation of back spindle. And below we have two M codes M702. To explain it, let's scroll up to the initialization. Please look into this code. This character 2 denotes Z-axis, in this case Z4. M2 denotes torque limit, and 22 is the value of this limit expressed in percents. Below we have the setting of servo lag. There is the value of 3000. It is expressed in tenths of micron, so it means that this is 0.3 millimeter. Of course, it doesn't mean that at this moment torque limit is activated as well as servo lag checking. This is only the definition, setting of values. Let's scroll down to our pickoff, and here in this code there is the activation of torque limit, and below activation of servo lag checking. Torque limit prevents from damage, serious damage, during pickoff when any collision happens, and checking of servo lag makes possible to detect situation when back spindle cannot reach the given pickoff position, for instance because of chips. Below is macro G924, which executes pickoff. You see. It performs movement of back spindle along a bar by a given distance Z. When this position is reached, collet closes. Next block is cutoff. As you see here, first cutoff tool goes to the center of a bar and next beneath the bar. Simultaneously with this finishing of cutoff, back spindle retracts by 2 mm. This command allows us to check if cutoff was done successfully. If a part wasn't completely cut off, then with limit of a torque, There is an overload of Z4 axis when back spindle retracts by this 2 mm. Then machine goes into alarm and everything stops. If cutoff was successful, then we disable servo lag checking and we deactivate torque limit, and this is the end of cutoff. Then back spindle fully retracts. End of a loop is reached then. It is programmed by M121, and execution of the codes, ISO codes beneath, depends on the status on the control panel of a machine. If a button stop at the end of a part is off, then we have direct jump to the beginning of a loop and the next part is produced. If it is on, then rotation stops, all rotation stops, coolant stops, and we can open machine door to check part dimensions or to remove chips. If we haven't pressed reset button, then we can resume machining by pressing cycle start, and then the jump to the beginning of a loop is executed. Otherwise, there is the end of a program. This jump to the beginning of a loop. Please notice what is the final position of cutoff tool after cutoff. It is beneath the center of a bar. It means that it is exactly the same position as after initial cutoff and before beginning of a loop.